Okay, 3.2 CA1 number 7, equation of a tangent. We need point, we need slope, so we need the derivative. 2y dy dx. And derivative of 27 is 0. Get dy dx by itself. Negative 2x divided by negative 2y. And then just plug in the x and the y. So the slope will be at 6, negative 3. Plug in that x is 6. Y is negative 3 and the slope is negative 2. And they just wanted the equation of the tangent. So you've got your point, you've got your slope. Y minus y1 equals m times x minus x1. And that should be it. Now I'm going to do number 10. Okay, so this one, remember when it says horizontal tangent, that means slope is 0. If it says vertical tangent, that means slope is undefined. To find when the slope is 0, you set the numerator of the derivative equal to 0. To find when the slope is undefined, you set the denominator of the derivative equal to 0. So I'm going to do the derivative. So 2y dy dx minus 4 dy dx. Now you have to get the dy dx by itself. So you're going to factor it out. Factor out the dy dx, and you're left with 2y minus 4, and then divide both sides by it. Now you can choose to simplify that if you want to, since you can divide everything by 2, or just take it from here. So now is the part where, to find where the derivative equals 0, we're going to set this numerator equal to 0. And to find where the derivative is undefined, set the denominator equal to 0. Okay, so this one will be when x equals 2, and this is going to be when y equals 2. Now the last thing you got to check is, okay, a horizontal line is supposed to go this way. It's supposed to be a y equals number, and we've got x equals 2. So we know the point that we need, but we need the vertical tangent there. So take what x equals. I'm sorry, this is a vertical line. We need a horizontal line. We need a horizontal tangent. So take what x equals and plug it into the original problem and solve for y. Same thing for this. That's a y equals equation, but we need a vertical line. We need an x equals equation. So basically, you're just going to take these, plug them into the original equation, and solve for the other variable. So when x equals 2, we're going to plug it in x here and here of 2. You get 24 minus 2 squared is 4 times 3. And now we have to solve for y. So 12 equals y squared minus 4y. Set that equal to 0. Now maybe it's factorable. Can you come up with two numbers that multiply to negative 12 and add to negative 4? And I think we can, 6 and 2. So we can factor it to solve it, but if it wasn't factorable, then we would have graphed it and looked for a height of 0. So this one we can factor, 6 and 2, and get y equals 6 and y equals negative 2. And those are the answers for the horizontal tangent. Y equals 6 and y equals negative 2. Now do the same process to find the vertical tangent. Plug in y equals 2 to the original and solve for x. So take it from there. So plugging in that y equals 2, I get this. Set it equal to 0. And then factor if you can. And if you can't factor, then you graph it and look for a height of 0. So I tried to factor, didn't work. So I could either use the quadratic formula and get a decimal, or graph it. And again, put all of this into y1 and look for height of 0. And if you look at the answers, you can see that they're decimal answers. So you know they either used the quadratic formula or graphed it. Either way, it's a decimal. So you had to use a calculator. And those were the two answers. Okay, hope that helped. Thanks for asking. Bye. Oh, this goes, by the way, that answer goes with over there at... this goes with vertical tangent.